Hello, everybody. This is Mr. Cousage. Welcome back. This is lesson 6-4. Don't forget to date your notes. Partial fractions. What are partial fractions? Well, before we get into that, let's do something that we already did. That is adding two fractions. Okay? So notice that when we have to add two fractions, we need common denominators. So I'm going to make common denominators. So I'm going to multiply top and bottom here by x plus 4 and top and bottom here by x minus 5. Why? Because now the denominators match. Now the denominators match. And that's the only time I'm allowed to add fractions. So now I add the fractions. How do you do that? You keep the denominator, right? You keep the denominator and add the numerators, right? So plus negative is same thing as minus. And then what? Well, then just simplify the top. 2 times x, 2 times 4, negative 1 times x, negative 1 times negative 5, and you get this on top, right? And on the bottom, you multiply that, and you get this, right? X squared, negative 20, and then the middle part, FOIL method, right? FOIL. So if we combine this, it all comes down to this. So what just happened? What just happened was we added these two fractions, and this was our answer. So that's what I wrote down here, right? The addition, the sum of those two fractions is equal to this answer, right? So what we want to do is go backwards. What if I gave you this? What if I gave you this? Can you split it up into the two fractions that were added to get this? Well, those are called the partial fractions, right? So we want to decompose, right? Decomposition of a fraction into partial fractions, okay? Well, where did this 2 and negative 1 come from? I don't see that anywhere. I know where these two came from. Like if I factor this, it'll come out to x minus 5, x plus 4. But where did 2 and negative 1 come from? So let's find out. So how do we do this? Okay. Let me focus you on just this fraction, right? So this fraction came from adding two fractions, and we want to know what those two fractions were. We want to know what the partial fractions were that were added to get this. So here we go. We don't know what they are, right? So for the numerator, we're just going to hold a place with these capital letters, A and B. We don't know what the numerators are. But the denominator, we know what it's going to be, right? If we factor it, it's going to be x plus 4, x minus 5. By the way, notice that I'm using what we started with here, right? I'm using this. So when I'm done, I should get this. Okay? So let's pretend we don't know what the fractions are. We don't know that it's 2 and negative 1 up there. So now what? Now that I've factored the denominator and split it up like this, now what? Now multiply by the common denominator, right? So here you want, because you want to match this, right? So here we have x plus 4, we need x minus 5, top and bottom. We have x minus 5, so we need x plus 4, top and bottom. Right? Now what? Now, well, now we have the denominators all match, right? The denominators all match. So really, what we have, we can ignore. We can ignore the denominators because they're all the same, right? So really, what we have is x plus 13 has to equal this plus this, right? What happened to the denominators? We are ignoring them because they're the same, right? Now what? Well, Let's simplify. Let's multiply n, right? Let's multiply n, and we get this, right? Let me move it up a little bit, right? We get multiply n, and we get ax, a5, and over here we get bx, b4, right? Now let's rearrange so the x terms are together, right? And the number terms are together. Let's rearrange. There it is, right? So ax plus bx, right? They belong together, and these go together, right? Now what? Well, we can put these together. We can factor out the x and call this, right? Factor out the x and call this a plus b times x. Okay? Are you with me? So now we're almost there. Look at the left side, look at the right side. Now we match. Notice that there's a 1x here and a plus bx here. So the 1 matches the a plus b, right? And the stuff without the x is 13. The stuff without the x is minus 5a plus 4b over here, right? That's a plus. So that matches. This goes with this. So I hooked them up like this, right? The x matches this, right? The x term matches the x term. The non-x term matches the non-x term. So this equals this equals this. That's what I wrote down, right? One, we can drop the x, right? Because it has to be 1, it has to be equal to a plus b, because this is equal to this. So 1 has to equal to a plus b, and 13 has to equal to negative 5a plus 4b. Okay, stare at that for a second. And now what we have is two equations with two unknowns. So let's put them together like a system of equations, like that. Right? Now you can use any method you want. The elimination method, the substitution method, okay? I use the substitution method. So if I change this to a equals 1 minus b by moving the b over here, then I can plug in the 1 minus b here. Right? Substitute the 1 minus b here. So I get this equation with all b's. Solve that equation, and you get b equals 2. Okay? And now we come up here. We come up here, now that we know b is 2, so a must be 1 minus 2. So a is negative 1. So then we know, right? Remember how this started? We needed a and b, right? Well, we got a and b. So now we know that we started with this, and it came out to be equal to this plus this. So all I did was find a and b and replace them up here. Okay? And that's what we expected to find, right? The 2 and the negative 1. Okay? So use this example as a template and try to do this one problem, and I'll start you off. So how does this work? Well, you split it up into two fractions with plus and ab here. And then you take the denominator and factor it. And then you use the common denominator, right? Make common denominators, and then you keep going. All right? Do the best you can, and we'll finish this in class. All right. See you later for part 2. Bye.